Hi students, welcome to the next topic from magnetic effect of current. Okay, so far we have learned about many concepts. So again, this is a continuation of the chapters. Okay, so let's move to the next topics and which is related with magnetic effect of current. So write on the heading helical motion of a charged particle. Helical motion of a charged particle in a magnetic field. In a magnetic field. This is a topic. Helical motion of a charged particles in a magnetic field. Helical motion. What is helical? Of course, you know, like it is, like this structure. This is called the helical motion. Helical motion of a charged particles in a magnetic field. So let's have a look into how this is possible. Let's assume you have a magnetic field like this. So this is the direction of magnetic field. And a positive charged particle is moving in this directions with a velocity called v. And this is making an angle of theta degree with the horizontal. So what will happen? This is contributing to, so this is the velocity vector along the direction and the magnetic field is from left to right. So in this case, what will happen to the charged particle? This is the context of the discussion. And this will undergo what type of motion? Helical motion. How the helical motion is possible? That's what we are going to see. Now, if if velocity is not in the x direction, if velocity is not in the y direction, according to two-dimensional motion vector analysis, we can divide this into two parts, x component and y component. If anything, any physical quantity, any vector physical quantity in physics is occupying a space between x and y axis, then it can be splitted into two parts. Okay, x coordinates and y coordinates. So x coordinate in this direction. So here what will be the x coordinate will be coming along the direction of theta. It is called v cos theta. The other perpendicular component is called v sin theta. So v cos theta and v sin theta are the two components. Next, we know v cos theta is along the direction of magnetic field. We know the magnetic force Fb will be equal to Q into v cross b. This is what we have writing, or we will write QVB sin theta. Okay, so what is this indicate? Theta is the angle between velocity vector and magnetic field vector. Now we have two velocities vectors will be there. One you can see v cos theta along the direction of b. Okay, v cos theta along the direction of b. So I can write it as FB. One parallel things will be there. What is that? Q into v means v cos theta into b into what is the sign of angle between these two, v cos theta and b, both are in the same direction. So angle is 0, answer equal to 0. Next one, that is a perpendicular magnetic field exists. What is that one? Q into, okay, v sin theta into b. Okay, or I can say, in short, I can say in two ways. Okay, listen to the diagram. So velocity vector is in the same direction. So here I can say, in short, I can write angle between, instead of going to formula, we can specify it in theoretical wise. Angle between v and b in this case is what? Theta equal to 0 degree. Okay, v cos theta and b. So here also angle between v sin theta and b, angle between v sin theta and b is equal to 90 degree. Now we'll go to the formula what we have written before. Magnetic field parallel will be equal to Q into v is what? V cos theta into magnetic field into angle between v cos theta and b is how much? Sin 0, answer equal to 0. Next one, magnetic field vector quantity Q into v sin theta into B into, what is the angle between V sin theta and B? V sin theta is like this, B is left to right like this. So angle between them is sin 90, answer equal to QVB sin theta. So only one force exists and that force is called QVB sin theta. Now I want to know the direction of FB. How to know the direction of FB? We know we have to use Fleming's left hand rule. As per Fleming's left hand rule, velocity is given by the middle finger. Magnetic field is given by the your forefinger. So magnetic field like this, velocity is upward. You can see this is velocity, this is magnetic field. So my thumb is into the board. My thumb is going into the board. If thumb is going into the board means what is happening? It is pulling inside. So it will undergo. So a charged particle is moving like this one. I mean moving like this. You have to assume the situation. See, a charged particle is moving like this. In this direction a charged particle is coming. Somebody is pushing inward. Who is pushing inward? FB perpendicular. FB magnetic field is pushing upward. So FB magnetic field is pushing upward means the particle which is coming like this will undergo this type of motion. So always the particle will have a tendency to go like this, but it is not allowing to go in a straight way. Instead somebody is pushing in this direction. So it will go in a spiral binding like structures, and that is called helical structure. Okay, so which means a charged particle, you have to write as a charged particle entering to a magnetic field, charged particle entering into a magnetic field where V makes an angle, theta with whom? With magnetic field, right? V makes an angle theta with the magnetic field. Then the positive charged particle, undergoes what type of motion? Undergoes helical motion. So if a charged particle is entering to a magnetic field with a velocity called V, and the V makes an angle called theta, then V cos theta is not contributing to any force, but V sin theta is contributing to a magnetic force, and that magnetic force FB QVB sin theta, other one is 0, which means V cos theta is not giving any force. Instead V sin theta is giving a force. Because of this one, somebody is moving like this one, somebody is pushing inward. So what will happen? This will go like this. That motion is called what is called helical motion of a charged particle in a magnetic field. So last sessions we have seen, when a charged particle entering to a magnetic field, perpendicular magnetic field, then it will undergo what type of motion? Circular motion. If it is not entering perpendicular, if it is entering with an angle called theta, and theta is not 90 degree, then it will undergo helical motion. If a charged particle is entering parallel to the magnetic field, if a charged particle coming like this, instead of like this, if a charged particle is coming like this, suppose if velocity is like this, let me explain. If velocity is like this and magnetic field like this, what is the angle between V and B? Angle between V and B will be equal to 0. So we got Q into V cross B is equal to 0. Hence no magnetic force is acting on the charged particle if velocity and magnetic fields are parallel to each other. This is the intentions will be here. Whenever the charged particle is parallel to velocity and magnetic field is parallel to, whenever velocity and magnetic fields are parallel, then there is no force. So whenever velocity and magnetic fields are perpendicular, okay, then what will happen? Circular motion. So three contests. When V and B parallel, So what will happen? Whenever it is coming in a straight line, nobody is pulling. So if it is coming, no push, no pull, nobody is applying, so force will be equal to 0. When B is like this and velocity is like this, both are perpendicular, then I know FB will be equal to QVB because we have sin 90. So this will undergo what type of motion? This will undergo circular motion. Circular motions. Next context, the last one. When B is like this and velocity is like this, makes an angle called theta. Then here sine become 90, but here sine is not 90. Instead what we will get? We already got, right? QVB sine theta. QVB sine theta. So this is what type of motions in this context? It is called a helical motion. This is called a helical motion. Okay, so hope this is clear. When velocity is parallel to magnetic field, no force. When velocity is perpendicular to magnetic field, circular motion. When velocity makes an angle theta with respect to magnetic field, then this will undergo helical motion. This is what we have seen. Okay, now we need to analyze this in a bit more way. Okay. So what is this factor is indicating to us? Now, as like what we have done in the last class, when velocity is perpendicular to the magnetic fields, we have derived certain set of equations for radius, time period, etc. But here we have something extra things will be here. Helical motion is related with one term called pitch. I'll tell you what is called pitch. Before that we will derive it. Now we know because of the magnetic field, this will get a helical motion. Helical motion means it's an inclined circle. Right? Circle is perfect. When it become inclined like this, then it is called helical motion. So if it is in helical motion also, there still magnetic centripetal forces exist. So in case of helical motions, we can written as FB will be equal to centripetal force. What is FB? FB we know QVB sin theta. Okay, QVB sin theta, that's all. What is FC? MV square by R. What is contributing to this one? V square. MV sin theta. MV cos theta has no effect. V cos theta has no effect because B and V cos theta are in the same direction, so which has no effect. Only effect is with respect to what is called V sin theta. MV sin theta square by R. So what will get? QVB is equal to MV square sin theta divided by R. So V get cancelled. R will be equal to what will come? MV sin theta divided by QB. Previously what we have learned for, if you look back a couple of pages into your notebook, when a charged particle entering to a perpendicular magnetic field, it will experience a circular motion with radius equal to MV by QB. But here it is not MV by QB, here it is MV sin theta by QB. Okay, next factor. So radius we find out. Next factor is called a time period. Time required to complete one revolution. So time period, time is always what? Distance divided by velocity. Distance by velocity is called a time period. What is distance? 2 pi r. What is velocity? Velocity, from this one we got velocity is equal to QBR, correct? QBR divided by M. QBR divided by M. That's all. Here velocity means what velocity matters will be not V cos theta. Here velocity means V sin theta, because this is a single component, not V alone is not a component. V sin theta is matter will be here. So R can cancel, M will go to numerator, so it become 2 pi M divided by QB. This is the expressions for time period. Next one. In an helix, the distance between these two adjacent spiral stuff is called pitch. Okay, so what is called a pitch? So pitch is defined as the distance traveled over a time period, the distance traveled over a time period. This is called the horizontal distance. We can say the horizontal distance specifically. This is called the horizontal distance. So it is nothing but the distance. We know distance is equal to velocity into time from one dimensional motion, and this distance is called a pitch, and this is the horizontal velocity. This is the horizontal velocity into time period. What is the horizontal velocity? Horizontal velocity is v cos theta. So for pitch, what is contributing? Pitch is given by v cos theta. The horizontal, we know this will undergo a type of circular motion. Who is giving the circular motion? Because of the magnetic force. But it is not a perfect circle. It is not moving here. The circle is moving forward. If the circle is moving forward, means somebody is pushing in forward direction. Who is that push? That distance covered over this period of time, it is called. That push is given by v cos theta. Because of v sin theta, you have a circle. Because of v cos theta, you have a velocity in the x direction. So the horizontal motion is because of v cos theta, and the perfect circular motion is due to v sin theta. So the horizontal component, this is the horizontal distance, horizontal velocity. So v cos theta into time period. So what is v cos theta? What is time period? 2 pi m divided by qb. So this is the expressions for pitch. This is the expression for pitch. So we have seen many things. So magnetic force will be equal to centripetal force, because circular motion is related with a centripetal force. Okay, centripetal force is towards the center, and also in laws of motion you are learning something called centrifugal force, which is away from the body. So for that you have to watch that lecture videos to understand and to know the problems from laws of motions. Okay, so FB will be equal to FC, QVB sin theta, FB magnetic force, and this is equal to the centripetal force MV sin theta by r square. So to know more about centripetal force and to know more about centrifugal force, you have to watch my laws of motions video. They're very detailed. It's explained about the circular motions and its properties. So to know that, you have to go and watch this circular motions videos from laws of motions. Okay, so FB is equal to FB, QVB sin theta, MV sin theta square by r. You know it is called centripetal force. Centripetal force is given by perpendicular magnetic field is only giving rise to magnetic force. That's what we have taken MV sin theta into taken account. Distance by velocity. Velocities will be here. What velocity? What velocity is contributing to the circle? V sin theta is contributing. V sin theta is called perpendicular velocity. And when come to pitch is a distance. It's a horizontal distance covered over a time period. So horizontal distance means horizontal velocity into time period. So horizontal velocity is v cos theta, time period is 2 pi m by qb. If you multiply these two, you will get the terms which is called pitch. That's enough. So three terms: radius, time period, pitch. Okay, I have to give two informations to you here. V perpendicular velocity is called v sin theta, and parallel velocity is called v cos theta. So the radius equations can be also written based on this. R will be equal to, we know mv sin theta. This we can written as mv perpendicular. Some reference textbook you can also see this one, mv perpendicular by qb. Anyway, this is not depends upon any other factors, 2 pi m by qb. So nothing is related to this one. And pitch equations, v parallel into 2 pi m by qb. You might seen in some reference textbook in case if you are referring something in future. So v parallel 2 pi m by, v parallel means v cos theta. That is the intention here. And R equal to mv perpendicular divided by qb. Hope these three parameters you understood what it means to say. Okay, we'll see a few questions related to this concepts, some few problems, then we'll go forward after doing the problem. Okay, so the first questions to us. We have a magnetic field in this direction and a charged particle entering with a velocity 2 into 10 power 3 meter per second makes an angle of 30 degree. And the value of magnetic field is, the unit of magnetic field is called Tesla. It's called Tesla. Okay. So B is equal to Tesla. Tesla is the unit of magnetic field intensity. So you can write it as unit of B is called Tesla. If you don't know, write it some. So velocity is given by 2 into 10 power 3. And what we need to find out? We need to find out R. We need to find out pitch. We need to find out time period. And last one, what is the trajectory of motion. Trajectory means itself it's called motion. So what is the trajectory, what is the path of this one? This we are going to see. We know the formula, R will be equal to mv sin theta divided by qb. So m into velocity is given 2 into 10 power 3. So 2 into 10 power 3 v sin theta, theta equal to 30 degree. So sin 30 whole divided by q into b is called 1 Tesla. So sin 30 is 1 by 2. 2 and 2 will get cancels. So 10 power 3 into m divided by 2 and 2 cancels divided by q. This is called the radius in meters. Next one is called, I am going to find out time period, then we will come to pitch. 2 pi m divided by qb, because if I get time period, it is easy to find out pitch. So 2 pi m divided by q into b is called 1. So it is nothing but 2 pi m divided by q. Okay, and the next one, it is related to called pitch. We know pitch will be equal to v cos theta into time period. V is 2 into 10 power 3 and it's cos 30 and which is into time period 2 pi m by q. 2 pi m divided by q. If m value, q value it is given, you have to use that value. Okay. Then 2 into 10 power 3 cos 30 means root 3 divided by 2 and 2 pi m divided by q. 2 and 2 will get cancels. So we will see. So 2 pi m, this 2 pi m root 3 into 10 power 3 whole divided by q. This is called a pitch. And the last one, what is the trajectory? Trajectory of the motion is what type of motion? It is, trajectory is helical motion. Helical motion in what direction? Along the direction of B. Helical motion along B, along the direction of B, which means the motion is like this. This is the helical motion. Okay, so trajectory motion along the direction of B, and that is the background of this question. So hope this is clear. One velocity and one magnetic fields are given. Based on that we have calculated radius, time period, pitch and then trajectory. So hope this is clear to you. We'll move to the next questions related to this helical motions. Okay, fine. Understand and learn it in a conceptual way. Then physics is easy. Instead of by hearting some formula, some definition, that will never help you. So understand what it is. Okay, then it is easy for you to learn and understand. Let's write the next question. A charged particle moving with a velocity v vector v is equal to 3 I cap plus 4j cap in a magnetic field vector b is equal to 4j cap. Find radius, time period, pitch and trajectory. So velocity will be given 3I plus 4j, magnetic field is 4j. So we know magnetic field is 4j means magnetic field is in what direction? It is along the j direction. So B is equal to 4j, we know. And velocity will have two components. One is the x component which is called 3I and one is the y component and which is called 4j. Okay, so we need to find out r. So r will be equal to, we know in case of this one, velocity is not perpendicular. Velocity is having two components, x and y components. So mv sine theta divided by qv. For this one, I already told v sine theta is the perpendicular component. So I already told write this one, right? V sine theta is called v perpendicular. Perpendicular to what? V perpendicular means, okay, V perpendicular to B. Magnetic fields in a perpendicular on the components. So magnetic field is in the direction of 4j. So what is the perpendicular component will be here? I am writing mv perpendicular by qb. What is a perpendicular component? Magnetic field is in 4j. What is perpendicular? 3I. You have to take it as 3. So m into 3 divided by q into 4. 3m by q4 is the answer for this question. Okay, we can written in a neat way. 3m by 4q. 3m by 4q is the right answer for this one. And the next part of the question is time period. T is equal to 2 pi m divided by qb. Direct formula. So 2 pi m divided by qb. B become 4. So it become 4q. And the last one is called pitch. And pitch will be equal to V parallel into time period. What is parallel component? Parallel to magnetic field. Parallel to magnetic field is what? 4j. So 4. J is the direction, right? X, Y, A, Z direction. I, J, K. I means X direction. J means Y direction. Z means K direction. So same thing. So 4 into, what is the time period? 2 pi m divided by 4q. 4 and 4 get cancels. You will get 2 pi m divided by q. So we got pitch, we got radius, we got time period. Next one is trajectory. Trajectory means whenever the velocity is perpendicular to magnetic field, only one velocity. It is purely perpendicular to magnetic field, it will experience a circular motion. If it is parallel to magnetic field, it will experience no force. If it is not parallel, not perpendicular, not parallel, but some other angle. If you see the resultant of these two vectors, this is like a 3I and this is like 4j. So what will be the resultant? Resultant will be coming 3 square plus 4 square, which is root 25, which is equal to 5. So this will make some angle called theta. So this is not perpendicular. The resultant velocity makes an angle. So this is the, see, this is the resultant. This is a magnetic field. So with respect to magnetic field, this is makes an angle called theta. Theta is not 0 degree. Theta is not 90 degree. Theta is some other value. Then what type of motion? It is a helical motion. In what direction? Along the direction of B. So the final answer, trajectory. And the trajectory is like this. Like this. So you can say helical motions along plus j direction. Plus j means along the magnetic field direction. So two vectors is given. This is called v cos theta is this is the perpendicular magnetic field. Perpendicular magnetic field is nothing but v sin theta. This is magnetic field. So this is v sin theta, and this is the parallel component, and this is called v cos theta in this diagram. That's what for v cos theta we have substituted 4 because it's a parallel component of velocity. And if two components will be there, how to find the resultant? Root of a square plus b square plus 2ab cos theta. Theta is the angle between the two vectors. So resultant equal to root of a square plus b square plus 2ab, 2 into 3 into 4 into cos of angle between 4 and 3. It is 90. So this factor is 0, right? Cos 90 is 0. That's what we are written, root of 3 square plus 4 square, which is equal to 5. 5 is the resultant velocity, and that resultant velocity makes an angle theta with the horizontal, and 4j is called 5 cos theta, and 3 is called 5 sin theta, v sin theta and v cos theta. So based upon that's what answering. So we know the velocity is not perpendicular to magnetic field. Velocity is making an angle of theta degree with respect to the magnetic field. Hence it is undergoing an helical motion along the direction of B, which is along the direction of positive j direction. Okay, hope this is clear to you. Fine. So we are going to see now few more stuffs over will be here. Understand the concept and then learn. Do not by heart anything. It will be getting confusing to you. Okay. Write down the next heading, and which is called Lorentz force. Lorentz force. Listen. If you have a charged particle and if you have an electric field will give rise to an electrical force. This we have learned in electrostatics, right? Fe will equal to Qe. E is a vector quantity, F is a vector quantity. Whenever a charged particle is entering to a magnetic field, positive charged particle with a velocity, it will undergo what type of motion? Circular motion, and this will experiences a magnetic force. Fb will be equal to Q into V cross B, which is QVB sin theta. So what is the Lorentz force? Lorentz force is talking about the combination of electrical force and magnetic force. Lorentz forces are talking about the combination of electrical force and magnetic force, which means in presence of, write down, in presence of E and B. Whenever you have an electric field and whenever you have a magnetic field. So in presence of electric and magnetic field, total force, net force will be equal to electrical force plus magnetic force. Total force equal to electrical force plus magnetic force. Oh, what is electrical force? Sorry, what is electrical force? Which is called QE. What is magnetic force? Magnetic force is called QE. And this is called V cross B, and this net force is nothing but it is called Lorentz force. In presence of electric and magnetic field, F net will be equal to Fe plus Fb. So and this is a total force, and this total force which is called F net is equal to Fl, that is called Lorentz force. This is called Lorentz force. So this is a highly important area in this chapter where we are going to see what will happen? So far we have seen like whenever a charged particle is entering to parallel to the magnetic field, it will not experiences any force because magnetic force is equal to 0. Second point, whenever a charged particle is entering perpendicular to the magnetic field, it will experiences a circular motion. Whenever a charged particle is entering at an angle theta with respect to this magnetic field, it will experiences an helical path. But here, now we are going to see whatever we have learned in electrostatics, or in simply electric charge, electric field chapter, we are going to apply here also. Which means now we are come to a common platform. What will happen? So far we have learned about what will happen if magnetic field exists. There is no motion, there is no force, there is a circular motion, there is an helical motion, like that. Now here we have an additional presence of electric field. If you have an additional presence of electric field along with the existing magnetic field, then what are all the things are happening for a charged particle? This is the context will be here. Hope you understood. Lorentz force is talking about two things. Partially Lorentz force 50% is coming from electric field and electric charge, rest 50% is coming from magnetism. So the combination of the electrical force and combination of the magnetic force together, add it up, it is called Lorentz force. So Lorentz force is dealing with the presence of electric field and magnetic field. Whenever only magnetic fields are there, we already seen so far in magnetism, and whenever electric field is only existed, so far we have seen in electric charge and electric field chapters. But now here we have two things will be there. One is called electrical force and one is called magnetic force. So these two together will give rise to something called Lorentz force. So Lorentz force is important. Based upon the Lorentz force, there are lot of questions will be coming. Okay, there are already some lot of questions are asked both for engineering side and for medical side. So what we are going to deal here after onwards, we are going to see different cases related with in presence of a charged particle. Now we have seen like charged particles are entering along the direction of magnetic field, no force. Charged particle entering perpendicular to the magnetic field, circular motion. Charged particle entering at an angle theta with respect to magnetic field, helical motion. Only magnetic field, magnetic field, magnetic field. Now it's not like that. Now the story is going to different. Now here we have magnetic fields will be there, electric field will be there. When a charged particle is entering to an area where electric field will be there, where magnetic fields will be there, what will happen? This is the context of the next topic. Hope so far up to Lorentz force it is clear to you. Next we have to go into see lot of different cases on the next further topics. Okay. So thanks for watching this sessions and have a nice study time.